Today we are going to discuss about what is automata based programming paradigm. In this automata based programming paradigm, we will be knowing what is an automata, what is an automata based programming paradigm, and what is an automata theory. What is an automata? It's going to be an abstract self-propelled computing device which follows a predetermined sequence of operations automatically. That is, you can take any computing device which is going to perform some sequence of operations automatically, then you can call it as an automata. What is going to be the automata based programming paradigm is, we can take any program or a part of a program that can be used as a model for a finite state automata machine. What is automata theory? Automata theory is a study of abstract computational devices. This abstract devices is the models of real computations. Computations happen everywhere. You can see it in the laptop, you can see it in the cell phone. Here we can take an example. We have a battery, we have a bulb, and we have a switch also. When you flip the switch, it's going to be on and it will make the bulb glow. And if you flip it again, it will be moving on to the off button. What are the two states that is followed in this example? We can see off state and we have seen an on state. Okay, the operation is going to be just flip, so we have F. It's going to be also called as an input. Okay, the start state will be represented with the help of a start button, and the stop state, that is going to be the final state, it's going to also be called as an good state. It's going to be represented with the double circles. Okay, so now it is in off state. When you are going to flip it from the off state, it is going to move on to an on state, which is going to make the light glow. And if it is in on state, it's going to move from one state to the other state, that is from the on state to the off state, with the help of a flip. So if you have some odd number of flips, this particular light will be glowing. If you have some even number of flips, this will be moving on to an off state. What are the different types of automata? We have a finite automata, we have a pushdown automata, and we have a tuning machines. In finite automata, we are going to have only a finite amount of memory, which you can use it for small computers. In pushdown automata, even though you have an infinite memory, it is just going to be in a restricted way, so you can use it in the model buses. And in the case of a tuning machines, you have an infinite memory, you can use it for any computers. In the finite automata, we are going to learn what is an alphabet, what is a string, and what is a language. What is an alphabet? It's nothing but the symbols. You can tell it as a pair of words, or you can tell it as a particular digits. Any way you can say it. So in general, an alphabet is a set of symbols. Here we have listed out some of the examples. We can see some set of letters in English from A to Z. This is going to be an alphabet. Some set of digits from 0 to 9, it's going to be an alphabet. And some set of letters plus and special symbol hash, it is also going to be an alphabet. And you have a set of open and close brackets, it's going to be an alphabet. And what is a string? All these alphabets will combine, or some of the alphabets will be combined to form a specific sequence of substring, then it is going to be called as a string. So in general, we can define a string over an alphabet summation is a finite sequence of symbols in summation. So from the set of the alphabets, we are forming a specific substring. You can see it has been from 0 to 9, all the alphabets. We are making a substring that is going to be 9021. So an empty string, if you want to represent, it will be represented in the form of epsilon. And what is a language? Language, it's going to describe the problems with yes or no answers. We have seen already some set of strings over an alphabet, but if you formulate as a sentence and if you write it, then you can call it as a language. For example, I want a set of strings that is going to have a substring as SRM. We will define the language as the set of all strings over summation1 that contain the substring SRM. We'll move on to the finite automata. This example is already dealt earlier, but we can see we have a stat state, we have accepting state. What is called as a good state? If a particular goal has been reached, then you can call that state as a good state. So when you have some odd number of flips, it will be moving from an off state to the on state. This on state will be called as a good state. So you can have an answers like F, a single F can move on to an on state, or else we have 3 F's. Okay, then it will be moving on to the on state, or else you have 5 F's. So if the F is going to be an odd, then you are going to move from an off state to the on state. The on state is going to be an accepting state, and it is also called as a good state. What is a deterministic finite automata? A deterministic finite automata is a 5 tuple. You're going to have some set of finite states, that is going to be Q, and you're going to have the summation, it's going to be the alphabet or the set of symbols, and you have del. The del will be represented as you have a state along with an input symbol. It will be moving on to another state. It is also called as a transition function. And you have an initial state. The initial state will be called as a Q naught, and you have some set of final states. It's going to be called as F, and the initial state will be represented with an arrow, and the final state it will be represented with double circles. And in the case of a deterministic finite automata, if you have an start state and you have an end state, you're going to read a particular input. It will move only to one state. If it is going to move to more states, then you call it as a non-deterministic finite automata. So there will be only one transaction for one input from one state to the another state. We can see an example here. We have an already defined example. So here, so the states are going to be, on state is the starting state, so Q will be represented as on comma off. So and on will be the starting state, and the accepting state is going to be off, and the alphabet is going to be F. And we have something called as a transition function. We have to represent a transition function. So the transition function is going to be, you can see here a state, it is off, it is going to read a symbol that is F, and it is going to move on to on. So it is going to be off, it is going to read an F symbol, and it is going to move on to on. Then we have on state, it is going to read F, and it is going to move on to off. So we have on, we are going to read an F, and it is going to move on to off. So we have another thing that is called as transition table. So transition table, you have states, and here also we have states. So we have off and on, and off and on. We have only two states, so it has been represented in the rows as well as here also. So here you can see from off to off is going to read F, and it's going to move on to on. So off is going to read F, and it's going to move on to on. Same thing, on is going to read F, and it's going to move on to off. On is going to read F, and it's going to move on to off. So this is called as a transition table. If I want to represent DFA, you have set of states, that is Q. You have the inputs, that is going to be F. We have the del function that we have represented already. We have a starting state that is going to be on, and we have a ending state, or we call it as an accepting state, it is going to be off. What is a language? We can say already it's going to be f of n, f of n, and n is going to be what? Odd. If the f of n is going to be even, means the total scenario will be different. The off state will be as an accepting state, and on state will be the start state. So the language depends upon how we are going to form the finite automata. So it has been represented in the curly braces. We are having the inputs F, and we have n, and n is an odd. Okay, we see some of the examples for the deterministic finite automata. The first example, you can tell it as an empty string. We are not going to read anything. We can have zeros and ones, but it is moving from the starting state, but it doesn't have an ending state. So that is what we have been representing as open braces and a closed braces. We are not going to read anything, we are not going to accept anything, so we don't have an accepting state. So it has been represented as q naught, so it is going to read 0/1. So in the case of the second one, we have an epsilon. If you have an epsilon state, means it is going to read an empty string. It is going to read an empty string. So obviously you are going to have an accepting state. So we have a q naught here. It is going to read an empty string. We won't represent this here, but you are going to read something that is going to be an empty string. But in case if it's going to read 0 or 1, it has to move on to another state. And even though after that also, if it's going to read some zeros and ones, it has to be moving on to some state. That state is not, it should not be an accepting state. So we'll move on with the third scenario. Third scenario, you can see the alphabets with the star, and here you can see the alphabets with the plus. This star and plus represents, in the case of star we can also take an empty string. In the case of plus, we won't consider this empty string. So in the case of star, we will be taking the empty string. In the case of the plus, we will not be taking any empty string. So what can be the possibilities? Because we have an input 0, 1, I can also represent this in the form of open braces 0, 1, closed braces, star. So what can be the possibilities of the string? You can have the possibilities as epsilon, that is an empty string. You can have zeros, you can have 1, we have 00, we can have 01, we can have 10, you can have 11. Like this you can form many strings. In the case of summation plus, we will be starting with 0, not an empty string. So 0, 1 and 00, you have 01, 10, 11. You can have any combinations. So how we are going to represent this as a DFA? So both the starting state and the ending state is going to be q naught. So you are going to read 0, 1, as well as we are going to have this empty state also. So once it enters itself, it is going to be an accepting state, and if it is going to read n number of zeros and 1, it's going to be moving on to the accepting state. But in the case of this summation plus, what is going to happen? The first thing itself, it has to read either 0 or it has to read either 1. So it has to either read 0 or it has to read 1. So you're going to start it from the q naught. First step, it will read any 0 or it can read 1, and it will move on to q1, that is going to be the accepting state. After that, you can read n number of zeros, n number of ones. That is based upon the possibilities. So this is how the small examples have been explained. We will move on with another set of example. Here we have a w. The w, we can take it as zeros and ones in this case. So w has an even number of ones. So when it wants to move on to the final state, it has to have even number of ones. It's not odd, it's going to be even number of ones. So I'm going to start with the start state. It's going to be q naught, and it's going to read 1, okay, and it is moving on to the another state. This another state, it should not be an accepting state because they have mentioned even number of ones. So from q1, it is again moving on to q naught, which I have made it as a start state as well as an accepting state. So when it reads 1 and again another 1, it is moving on to the final state. If it is going to read some zeros, there is no issues at all. So it can read n number of zeros, as well as when it is moving from a q naught to q1, you want to read any 0 and n number of zeros, it can do it. But only one condition has been mentioned. What is the condition is, you should have even number of ones. So you are going to read 1. When you read only one, it should be moving on to only the non-accepting state. When it reads the second one, that is, it has to move on to the accepting state. So here there is a specific condition. You can see it is a start state as well as it is an accepting state. Okay, then we will move on to the next example. We are going to build an automata that is going to accept all and only those strings that contain 0, 0, 1. So it is going to have 0, 0, 1. So we are going to start. You have a starting state that is Q naught. It's going to read 0. Okay, it has moved on to another state that is Q1. So 0, it has been read. There is another 0, so it has to move on from Q1 to Q2. So you have another 0. The next thing is you have a 1. It has to move from Q2 to Q3. So once it has read 0, 0, 1, it has to move on to an accepting state. So we have a starting state that is Q naught and we have an accepting state that is Q3. So in between you can have ones, you can read zeros. There is many possibilities. So as per the alphabets that has been given, it has to be 0 and 1. So for 0 we have already finished. What is remaining in the case of Q naught? We have 1. So it has to be read. So we have a self loop. So and in the case of Q1, you have already read 0 and you have 1. But in this case you have to remember, once the 0 has been read, the next that has to be read is 0. So in this case I can't put it a self loop. I can't put 1 as a self loop. If that is the case, what it will be read? It will be reading 0, then 1, then 0. So that is not possible at all. So this 1 I have to put it somewhere else. So I'm just moving this 1. When Q1 is going to read this 1, I'm just going to move it to Q naught. The next thing, so after 0 has been read, the another 0 has to be read. So that is okay. What is the next condition is, it has to be you have already given 1, no issues at all, but there is another input that is going to be 0. There has been a condition that has been given. You have to read many zeros and the last one has to be 1. Already we have read zeros. If you're going to have another 0 also, it is going to be 0 zeros only. So in this case, you can put a self loop for 0. And at the final we have finished, we have moved on to Q3. After that, so it is going to have a substring of 0, 0, 1. So after that I can read any type of strings. So I have a self loop. The self loop is going to have 0 slash 1, or you can also mention it as 0 comma 1. So this is another example for the DFA. Okay, now we are going to see how we are going to implement in the case of Python. So for implementing in the Python, the first thing we are going to use a package that is going to be called as Automata dash lib. So you have to install in your Anaconda or Spider pip install Automata slash lib. Okay. Then we are going to do DFA here. So when you want to use the DFA, you have to import the package. For importing the package, this syntax has to be used. From automata dot, we are going to take finite automata, so we have to use FA dot, we are going to use deterministic finite automata, so you have to use deterministic finite automata. In that we are going to use the package that is DFA. Everything should be in capital. DFA, it has to be in capital. Okay, the next thing is we have to mention all the 5 tuples. We have already said about the tuples. What are the tuples we have? We have Q, we have the input symbol that is summation, we have the transitions that is going to be the del, we are going to have the initial state that is going to be the Q naught, and we have some set of accepting state that is going to be the F, capital F. So the first thing, we have set of states. So states has to be represented. So states equal to, we have to open it with the curly braces. Each and every state has to be mentioned inside the single quotes. So for example, we have discussed off and on, right? So how you'll be representing states equal to, we will be opening it, we will put off, we will put it as on. Okay, the next one is we have to mention the input symbols. So input underscore symbols equal to, we have used in that example only an input symbol f, so that has to be represented in the single quotes f. Okay, and we have some transitions, we have already dealt the transitions, that is going to be del. So in that, in the case of off, when you read the input symbol f, it is going to move on to on, so that has to be represented. So here we have a state, okay, that is going to be off, you're going to read f, and we are going to move on to off. Another state has to be represented. For example, we have on, it is going to read an f, and it is going to move on to off. So these, everything has to be represented. Remember, you have to start it with the curly braces and you have to finish it with the curly braces, and each and every transition you have to mention it with the curly braces. Okay, then we'll move on to the fourth part, that is going to be the initial underscore state, that is the starting state. So starting state, in that case we have taken off as the starting state, and what is going to be the final state? The final state is going to be the on, so that we have taken. Then after finishing off, we want to check whether a particular input symbol has been accepted or not. So in that case, we have taken odd number of f's. So if that is the case, what I can do, dfa dot read underscore input. In that, we are going to give f. If that is going to be accepted, it will be returning me as true. If I'm going to give odd number of f's, for example f f f, if that string has been given, it will be accepted. In this case, if I'm going to give an even number of f's, it will be returning me an error. Okay, the next one is we have dfa dot read underscore input underscore stepwise. If that is the case, what is going to happen is we will be traversing, we will be traveling the input symbol, what are the states it has been given. For example, we can take the previous example, we are giving an input symbol as 001. If that is the case, it is moving from q0 to q1, then it is moving to q2, then it is moving on to q3. So stepwise means it will be mentioning, if you are given an input symbol as 001, it will be moving from q0 to q1 to q1 to q2, then you have q3. So that stepwise transition will be mentioned in the case of read underscore input underscore stepwise. The last one is we have created an automata. We just want to check whether it is correct or not. If that is the case, you can give it as validate. It will be returning true if it has been represented in a correct way, or whatever automata you have created is correct, means it will be returning it as true. If it is going to be a wrong, it is going to be returning me as false. So these are the things that you have to consider in the case of a Python implementation. It is going to be a very easy one. We will take a simple example, then we will see how this particular DFA has been implemented in the case of with the help of Python. Okay, so here I am going to take a DFA. You can see a DFA which matches all binary strings ending in an odd number of ones. So you should have odd number of ones. Always in a substring, if you have odd number of ones, that has to be accepted. We have to design a DFA. So in that case, you can take q0. So q0 is going to read 1. So obviously it will be moving on to the accepting state. So it has been accepted. But you can't take only 1 alone. What are the other cases? We have to take 3 ones. We have to take 5 ones. Okay. In between you should also have zeros. Okay. So since it is in a deterministic finite automata, you can see q0. It is already read 1. So for that input case, it is over. But in the case of 0, what it has to happen? It has to read that 0. So always it should have at least only odd number of 1. So this 0, we are putting it as a self loop. Okay, the next one is we should have the n number of ones, which has to be odd. So we are going to start with a 1, then we are going to move on to the next one. If it is an even one, it has to move on to some other state. Then, and if another one is read, it is going to be an odd number of 1. So it will be moving on to this q1. So In the case of Q1, we have already dealt this one, so the remainder is going to be 0. So in this case, I can't take an even number of 1, we have to take an odd number of 1. So the 0 is moving on to the another state, that is going to be Q0. Then in the case of the last Q2, we have already mentioned 1. The remaining is going to be 0 alone, it will be put as a self loop. Okay, so this is going to be what? This is going to be the DFA diagram. And we have the languages. What can be the strings? The possible strings can be 1, or else you can have 0 and 1, or else you can have n number of zeros and 1. So it can be 001 or 0001, any number of ones. The next thing is, you can see 1, it has been read 1, then another 1, then another one has been read. So you have 3 ones. So that can also be a string that is going to be accepted. The next string is 1 1, you're going to read 0, then it is going to read 1. So that also can be an accepted string. So the next thing we have to always represent is, we have to represent this in a table. So we have seen a transition diagram, we have seen the languages, we have to see how a transition diagram has been mentioned. So we have mentioned all the states here as well as here, both horizontal and vertical. The next thing you have to see, Q0, it is going to read 0 and it is going to move to Q0 itself. So Q0 reading 0, it is moving to Q0 itself. Then Q0 reading 1, it is moving on to Q1. So Q0 reading 1, it is moving to Q1. Then rather than that, it is not moving to Q2 at all, so I am just putting it as dash. In the case of non-deterministic finite automata, there is a possibility of putting epsilon also if it is going to read some empty string. So in this case, we don't have such opportunity, so we just put it as dash. So the next one is, we move on to Q1. Q1 in this case, when it is going to read 0, it is going to move on to Q0. So Q1 is reading 0, it is moving on to Q0. Then Q1 is reading 1, it is moving on to Q2. So Q1 is reading 1, it is moving on to Q2. Then we have Q2. Q2 is reading 0 and it is moving on to the Q2 itself. So it is going to Q2 is going to read 0 and it's moving on to Q2 itself. If it is going to read 1, it is going to move on to Q1. So the table has been formed now. So now